Good morning, dear children of class 10. So today we will be studying a new lesson, that is organic chemistry. Organic chemistry. Now chemistry is a vast subject. So the compounds of carbon, especially compounds of carbon and hydrogen, hydrocarbons and their derivatives, are studied separately because they have similar properties. They are all covalent compounds. So they are studied separately. And the study of these organic compounds is called organic chemistry. So compounds of carbon and hydrogen and their derivatives are called organic compounds, and the study of these organic compounds is organic chemistry. So that means in organic chemistry we study about carbon and its compounds, but not carbon dioxide, carbonic acid, carbon monoxide. Few carbon compounds we do not study in organic chemistry. Okay, so only the compounds of carbon, hydrogen and their derivatives are studied under organic chemistry. Now, there are 118 elements known so far. 118 elements. There are 118 elements known so far. Out of these 118 elements, one element, that is carbon. Carbon is one element. Carbon is one element. Okay, out of 118 elements, one of the element is carbon. But the compounds of carbon are studied separately. Compounds of carbon. Compounds of carbon are studied separately. Why? Because there are millions and millions of carbon compounds. There are millions and millions of carbon compounds which cannot be studied together along with the other compounds like water, like sodium hydroxide, calcium hydroxide and all. So it has to be studied separately because there are vast organic compounds. So from our morning till we sleep, from our birth till we die, maximum substances that we use are all organic compounds. The food we eat are all organic compounds. So previously people used to think that the compounds that is derived from living things are only organic compounds. They used to say compounds derived from living things are said to be organic compounds. But later on, one of the scientists, he made urea, which is considered as an organic compound in laboratory. That means artificially he could make it. So from then it is believed that organic compounds can be prepared in laboratory also. But then also, since it was considered organic chemistry, organic compounds, so the name goes like that, only organic compounds. Rather nowadays if we say organic compounds are carbon compounds, then also it is okay, but organic compound can be used. Though they are not only derived from living things, they can be made in lab also, but then also they can be termed as organic compounds now also. Now one thing that is very important is, if you collect all the compounds made of 117 elements except carbon, then also then also it will be the collection will be very small comparing with the compounds of carbon. That means compounds of carbon are very large number of organic compounds are there. So one thing may come in our mind, one question may arise in our mind. You may be thinking, what is there in carbon, because of which carbon has large number, million and million of compounds. So what is there in carbon? There must be some unique property in carbon, otherwise the rest of the elements also would have made such huge compounds, but it is not. It is only carbon which has immense number of compounds, which can form immense number of compounds. So what is that property? What is that unique property? So unique property, unique nature, unique nature of carbon, unique nature of carbon atom. So what is the unique nature of carbon, or anomalous nature of carbon? Unique, which makes it different from other elements, which makes carbon different from other elements. It has unique nature because of which there are million and million of carbon compounds. So one may ask you question, why we study compounds of carbon separately in organic chemistry? In organic chemistry, why we study carbon compounds in organic chemistry separately? It is because organic compounds are large in number, million of organic compounds are there. Okay? Then why there are million of organic compounds of carbon? So there must be some uniqueness in carbon atom. So what is that uniqueness in carbon atom? That uniqueness in carbon atom is number one, tetravalency. Number one is tetravalency. Carbon atom has valency or you can write valency of carbon atom is 4. So valency of carbon atom is 4. Valency of carbon atom is 4. Carbon atomic number is, yes, 6. And electronic configuration will be 2, 4. Electronic configuration will be 2, 4. So the valence electrons in carbon is 4. Valence electron in carbon is 4. That means it can neither give 4 electrons nor receive 4 electrons. So one of the very much important questions regarding carbon is carbon cannot form compound by transferring electrons. Carbon cannot form ionic bonds because valence electrons in carbon is 4. That means it can neither give 4 electrons, because if it has to give 4 electrons, then use ionization energy is required. To remove 4 electrons from an atom, use ionization energy is required, and carbon being a non-metal, it has tendency to gain electron, not to lose electron. That means it cannot at all lose electrons, and that to 4 electrons. Number one. Number two, it cannot gain 4 electrons, because if it gains 4 electrons, it will be stable. If it gains 4 electrons, it will be stable. Or if it loses 4 electrons, it can also be stable. So I said, why it cannot lose electrons? Because for losing electrons, use amount of ionization energy is required, and that much energy is not possible. So it cannot give electrons. Now it cannot receive electrons also. Why it cannot receive electrons? Because number of electrons in carbon is 6, and number of protons is also 6. Now if it receives 4 electrons, then it will be 10 electrons. It will be 10 electrons. And these 6 protons cannot balance 10 electrons. These 6 protons, positively charged protons, cannot balance 10 electrons. As a result, it will be unstable. So carbon cannot form. So what is the conclusion of this? Carbon cannot form ionic bonds. All carbon compounds will have covalent bonds. All carbon compounds will have covalent bonds, because carbon cannot form ionic bonds. So why carbon cannot form ionic bonds? Because carbon can neither lose 4 electrons nor gain 4 electrons. Carbon can neither lose 4 electrons nor can gain 4 electrons. As a result, carbon cannot form ionic bonds. So carbon, then how carbon forms compounds? Carbon can share 4 electrons. Carbon can share 4 electrons. Okay, carbon can share 4 electrons with the combining atom. Carbon can share 4 electrons with the combining atom. For example, this is carbon, and it has 4 valence electrons. How many electrons it has? 4 valence electrons, and it can share 4 electrons. It can share 4 electrons. It cannot give or take 4 electrons, but it can share 4 electrons with the combining atoms, and hence its valency is 4. Its valency is 4. So that is termed tetravalency. Tetra means 4. Tetra means 4. Tetra means 4. So what is tetravalency? Tetravalency is the capacity of sharing 4 electrons. Capacity, that means the atom whose valency is 4. The atom whose valency is 4 said to be tetravalent atom. Said to be tetravalent atom. So carbon is tetravalent atom. Its valency is 4. It shows covalency of 4. It shows covalency. I am not saying electrovalency. Covalency. So it can share. Electrovalency means it can transfer, but covalency means it can share. So it can share 4 electrons, hence it is tetra. It shows tetravalency. Carbon atom shows tetravalency. And what is the benefit of showing tetravalency is carbon can combine with 4 different monovalent atoms. Carbon can combine with 4 different monovalent atoms. So it can make different compounds. For example, what is the valency of hydrogen? 1. So hydrogen can share 1 electron. Hydrogen can share 1 electron. So hydrogen can share 1 electron. This way, hydrogen can share 1 electron. And now these electrons, shared pair of electrons belongs to both the atoms. So this is 2. That means it has attained its duplet. This hydrogen also attained its duplet. This hydrogen also attained its duplet. This hydrogen also attained its duplet. So all hydrogen are stable now by sharing a pair of electrons. And then this carbon has how many shared pair of electrons? 1, 2, 3, 4. Count the electrons. 1, 2, 3, 4, 5, 6, 7, 8. So stable. This way carbon forms compound. So carbon can combine with 4 hydrogen atoms. Carbon can combine with 4 hydrogen atoms. And in place of this carbon, if you keep chlorine, then it forms a different compound. It forms different compound. Again, in place of this hydrogen, if you write fluorine, then it is different compound. And in place of this hydrogen, if you write CH3 methyl group, then it forms different compound. So this is the reason why carbon has huge number of compounds. One of the reasons why carbon has huge number of compounds is this tetravalency, because it can combine with. So why tetravalency is one of the reasons for carbon atom to have huge number of compounds, because it can link with the 4 different monovalent atoms. It can combine with different monovalent, 4 different monovalent atoms at a time. Hence, it can form large number of compounds. It can form large number of compounds. Then, this is one reason. Another reason is catenation. One is tetravalency, another is catenation. So one is tetravalency. Number one is tetravalency, and I think you have understood what is tetravalency now. So one is tetravalency, another is catenation. So what is catenation? Catenation is the property by virtue of which an atom can combine with. An atom can link with many atoms. An atom can link with many atoms. So catenation, the property of self-linking of atoms of an element through covalent bonds in order to form straight chain, branch chain and cyclic chains of different sizes is known as catenation. So what is catenation? The property of self-linking, the property by virtue of which a carbon atom can link with another carbon atom. A carbon atom can link with another carbon atom. An atom can link with another atom. And this catenation property is there in silicon also, because they lie in the same group. But then also silicon can go to some limit, but carbon doesn't have a limit. Carbon can link with any number of carbon atoms. Carbon can link with any number of carbon atoms. And not only in straight chain, it can have branch chain also, it can have cyclic chain also, it can have a ring chain, ring also. So in any form it can link with another carbon atom. So because this is another reason because of which carbon has a large number of compounds. So for catenation I am showing you. What is catenation? It is the property by virtue of which an atom can link with another atom of same type. And since this is especially found in carbon and we are talking about carbon atoms, so you can say catenation is the property by virtue of which one carbon atom can link with another carbon atom in straight chain or in branch chain. I will show you. So this is carbon, and carbon has tetravalency. Carbon has tetravalency. So this carbon can link with another carbon, another carbon, another carbon, another carbon, and so on. It can go on. It can go on. So this becomes a straight chain. Straight chain. The chain is going straight. The chain is going straight. So this is straight chain. So this is a straight chain. It is going. Then another is this carbon can have branch also. This is carbon. This can go like this. And again it is branching out like this. It can branching out like this, and again it can form branch out here. So this is forming a branch. So this is branch chain. This is branch chain. So it can form branch chain. And again another, this is carbon, this is another carbon, this is another carbon, like this. So in this way it can form cyclic chain also. This is cyclic now. Cyclic chain. That means here it is open on both the sides. Open chain. It is open on both the sides. Open chain. Straight chain is open chain. Branch chain is also open chain. But here you cannot see open chain. The chain is closed. The chain is closed. Hence it is cyclic chain. It is cyclic chain or closed chain. So in this way carbon can link with another carbon atom. Carbon can link with another carbon atom. Hence there is large number of carbon compounds. So what is the reason behind carbon having huge number of compounds? Number one is tetravalency, because of which it shows valency of 4. That means if it is combining with monovalent atoms, then it can combine with 4 monovalent atoms at a time, which results into huge number of carbon compounds. Another is catenation. It has the tendency to link with another carbon atom. And not only in straight chain, it can form straight chain, it can form branch chain, it can form cyclic chain. So it can result into different compounds. It can result into many compounds. For example, see here, if it is going like this, then it will be propane. It is propane. But if there is again branch, then it will be different compound. Again, if there is a cycle, then it will be again different compound. So in this way, it results into huge number of compounds. So more than 5 million organic compounds are known today, and thousands of new compounds are added every year to the existing lot. That means carbon has immense number of organic compounds because of these two regions. So question may be asked like, why carbon atom can have million of compounds? Then also your answer will be tetravalency and catenation. And what are the unique nature of carbon atoms? Then also your answer is tetravalency and catenation. So now tetravalency means valency of 4, catenation means self-linking property. So this much for today. So this is our introductory class for organic chemistry. So we'll be going on. Hope you are studying at home seriously. You need to go seriously, because we have finished almost 60 or 70% of our syllabus. So focus on your studies, and simultaneously you do your works also. Till then, stay safe, stay healthy, give time to your studies. Thank you.